Welcome guys. So yeah, welcome to my linear algebra video channel. In this video, let's talk about Rayleigh's principle. So before I start, please subscribe to my channel and click like button and the notification bell and comment what you learned below. Rayleigh's principle is a result that I think is famous in linear algebra and also in like quantum mechanics if you learn about the variational principle. So then let's quickly talk about the setting and the results, and we give the proof. Okay, so let's say A is an n by n matrices with the complex coefficient, and A is the same as Hermitian. So that means A is a so-called self-adjoint. If you restrict it to complex to reals, then A is called a symmetric matrix. Suppose the eigenvalue of A is the largest eigenvalue of A defined to be lambda 1, and second largest to be lambda 2, and the final to be lambda n. And define R of x. Right, x is I think it's the column vector defined to be x Hermitian. Just basically take a complex conjugate and take x. So this is a quadratic form divided by x Hermitian x. Okay, the theorem says that R of x, the maximum of Rx is lambda 1, and the lower bound is lambda n. And the lambda 1 can be achieved by some lambda 1 can be also defined to be maximum of R of x. Basically, this fact just tell you that there exists x such that lambda 1 can be achieved, and there exists some vector lambda n can be achieved. Okay, so basically, let's just say that this the maximum and the lower bound and the upper bound of this R of x is restricted by lambda and lambda n. Okay, so yeah, trivially. Okay, so I'll see a proof. Okay, so the idea of proof is very important. That if you don't know, I will leave my another video below. Basically, there's a fact that you must remember: if A is Hermitian, then A is diagonalizable, and moreover, this diagonal matrix can be choose to be unitary. So what it means is that there exists a P such that P is unitary. So P inverse is the same as is Hermitian, or somebody like use a dagger. Such that PHP equals 1 or P dagger P equals identity. Okay, so exists the P such that P inverse AP equals to lambda 1 to lambda n, and all these are 0, and this is called a lambda diagonal matrix. Okay, so that means you can write A as a P lambda PH. Okay, so let Y to be P inverse X, then original R of X can be changed to XH. So you just write A as P lambda phx and divided by xhx, right? And since P is unitary, so xhx can be just changed to yhy, right? And at least the numerator become yh lambda y. Okay, so write down the definition. This becomes the yi, basically each component square I from 1 to n, and take and this guy just the same, but there is a weight of lambda I yi squared I from 1 to n. Okay, and since lambda 1 up is greatest, right? So lambda 1 take the this expression will greater or equal to the separation lambda I yi squared I from 1 to n greater than lambda n I from 1 to n y squared, right? So we have this and this, right? So just put all of this information and divide by square y squared, then you get lambda. The original expression of x is greater or equal to lambda n and less or equal to lambda 1. Okay, and we can also prove, and it's obviously that this can be achieved because for lambda n, just pick the eigenvector corresponding to lambda n, and this guy just pick the eigenvector corresponding to lambda 1. Okay, so the proof is done and very trivial. Okay, see you guys in the next videos. Yeah.